All right, guys, what we're doing today is we're going to learn, well, actually, it should be a review. You did learn this in geometry and probably in Algebra 1. So what we are going to do today is we're going to simplify radicals. I'm going to first show you how to do the factor tree, which is personally the one I like better. And then I'm going to show you how to do the perfect square method also. So go ahead and get your notebook out or a piece of paper because, again, these are not guided notes. Okay, so first examples. We're going to do the factor tree. So let's start off with something easy. Let's start up with square root of 80. Okay, so again, what we're going to do is we're just simplifying these. The factor tree, you start to kind of make a tree and you ask yourself, well, what two numbers multiply together to give me 80? So let's do 8 and 10 because those are easy because it ends in a 0. Then you just keep moving. 4 and 2. Just keep moving down your tree. Now, you want to go until you're at a prime number. So remember, prime means 1 times itself. Okay, so like 2. The only thing that can multiply together to give you 2 is 1 times 2. That means 2 is prime. Okay, 10 is not prime because you can do 5 times 2. But then, now look at all of your lower level. I got 2, 2, 2, 2, and 5. Okay, so all the bottoms of my tree are prime. Those are the only numbers that you really care about, guys. You do not care about this 4, this 8, this 10, or this 80. You only care about these prime numbers. Okay, so now what we do is partners come to the outside and lonelies stay on the inside. Okay, so partners on the outside. Is that how you spell lonelies? That looks weird. And lonelies on the inside. All right, so here's a group of partners. Here's a group of partners. And then you have a lonely 5. Now, when you have multiple sets of partners, you just multiply. 2 times 2 is what? 4. And then you're lonely in the middle. 5. Boom. Done. All right, let's go bigger. Let's go 125. All right, so start your tree. Just think of things. You know it ends in a 5, so let's try 5. So that's 5 and 25. Now, 5 is prime because the only thing that multiplies together to give you that 5 is 5 and 1. Let's do 25. 5 and 5. Okay, now here's my partners. Here's my lonely. So again, partners go on the outside 5, and your lonely goes on the inside 5. So that one had both 5s. All right, so I'm hoping we're okay. Let's try a big one. Let's try, I'm going to squeeze them right here in the center. 320. Now again, it ends in a 0, so we should know 10, 32 and 10. Neither one of those are prime, so just keep on working it. 8 and 4. 8 is 4 and 2. 4 is 2 and 2. This 2 is prime. Let's do this 4. 2 and 2. Let's do this 10. 2 and 5. All right, so the end of our tree, remember, is the only thing we care about. We got a 2, 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 we got a 5. Oh my gosh, that's a lot of 2s. Okay, so you only care about the prime ones. I'm going to circle up the partners. Ooh, this time I have 3 groups of 2. So remember, you'd multiply anytime you have more than one group. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And then that lonely old 5. Okay? All right, so that's the tree method. Now let's talk about just the perfect square method. So all I'm going to do is I'm going to just write out the perfect squares. So 1's a perfect square. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 25. 36. 49. What am I on? Did I skip one? 4, 5, 6, 7. 8 is, oh my gosh, I put 81, but we all know it's 64. And 10 is 100. Okay, so these are kind of out of order. My bad. Okay, let's try one. So when you're doing the perfect square, you do not do the tree. what you do is you think about your perfect squares and you look for the biggest perfect square that is divisible by 45. So we know 9 can go in there. So square root of 9 times the square root of 5. Okay, 9 is the perfect square. He's the largest perfect square that can go into it. Well, what is the square root of 9? 3. And then the 5 stays in. That's it. It depends on what you like, guys. If you like the tree because you're kind of more organized, you like to see everything, then do the tree. If you can look at this and see the perfect squares, then do the perfect square. Let's get a big guy. So 162. When you're doing 162, I don't know, guys. I don't know how you're going to do it. But maybe you guess and check. So 162 divided by 4. Doesn't work. 162 divided by 9. It does work, but let's see if there's a bigger one. 162 divided by 16. Nope. 162 divided by 25. Nope. 162 divided by 36. Nope. Let's try the 49. And what's 64? Okay, so it might be, but it's not because it's not. Let's keep going. 81. There it is. See? I thought it was the 9 at first, but it actually is the 81. See, that's why I think the perfect square method sucks a little bit more because you have to check all of them. It has to be the biggest perfect square. So 9 did go into 162, but 81 is bigger. So we have the square root of 81 times the square root of 2. Okay, well, what's the square root of 81? 9. And then you have the square root of 2 left in. Okay, so you get to decide. I will take either one. I want to see some work on this example too so I can know what you're doing. Okay, but remember down here on example 2, highest perfect square. If you do not pick the highest perfect square, it's not going to be simplified enough. Okay, so go ahead and try a couple of the practice problems before you do your exit ticket.